A good day to all of you, and I welcome you all in this course on Introduction to Engineering Thermodynamics. In the previous video, we have talked about or we have discussed about the thermodynamics properties, state, process, cycle, and the thermodynamic equilibrium. In today's video, we are going to discuss about the quasi-static process. A quasi is a Greek word which means almost. Infinite slow is the characteristic feature of a quasi-static process. That means a process which is very slow is a quasi-static process. A quasi-static process is a succession of the equilibrium states. That means a process in which each and every state is an equilibrium condition. We call it as a quasi-static process. A quasi-static process is also called as a reversible process. Let's understand more about this quasi-static process with the help of the example. Let's take an example of the piston and cylinder arrangement. We are having a cylinder. So this is our cylinder. And in that cylinder, we are having a piston. This can reciprocate inside this cylinder. So this is your piston. And there is a gases inside this cylinder. Let's say this gas is having the pressure, temperature and volume of P1, V1 and T1. So P1, T1 and V1. So there is a weight over this piston which is having the W weight, and there is a stopper also so that this piston cannot go beyond this cylinder or go out from this cylinder. Let's say we are removing this weight from the piston. As we remove this weight from the piston, this gas will expand inside this cylinder and reach to its final position. Let's say it is reaching at this position. It is the final state. And this final state is described by the pressure P2, temperature T2 and volume V2. Now let's describe this process of the thermodynamic plane. Let's say we are having a thermodynamic plane where we are having the pressure and volume. Initial state is P1 and V1 and final state is P2 and V2. And the process is described like this. Initial state is in the equilibrium condition and final state is again in the equilibrium condition. But in between, we are having the lots of or the infinite equilibrium state because the process is taking place very fast. Now let's just change the arrangement of the system. Let's replace this W weight by a small weight. Let's say again we are having a piston and cylinder arrangement, and in this condition this W weight is replaced by small weight. Let's say this is having a 10 kg of weight. Now this 10 kg has been replaced by small 100 grams of weight. So this is 100 grams, this is 100 grams, this is 100 grams and up to the 10 kg. Now again we are having the gases here, and similar the pressure P1, volume V1 and temperature T1. Now we will remove this weight 100 grams. As we remove this 100 grams, the process will be changed to the reversible, and each and every state will be your equilibrium condition. Let's say initial is having the P1 and V1. As you remove 100 grams, it will like this, and as you remove more 100 grams, it will be go like this, and as you remove more 100 grams, it will be go like this, and like this you will be having the process of the final position, which is having the P2 and B2. And here each and every state having the equilibrium condition. So these are the equilibrium states. And this process, we call it as the quasi-static process. So this is the pressure and volume diagram. Here I only take the example of the 100 gram. If you reduce more weight, let's say you are taking the example of the 50 gram, then process will become more reversible. And if you take the 10 gram, then your process will become more reversible or the more slow. So as we are giving the definition, a quasi-static process is the infinite slow process. So as you reduce the timing of the process, your process will become more and more reversible and quasi-static. I hope that you've understood about the quasi-static process. Thank you very much. Have a nice day. God bless you.